Hello, I'm Min, and today I'll be going over number 2 of the Chapter 2 FRQs. So first, we are given the curve y squared minus x squared y is equal to 6 for y is greater than 0. We're given the derivative, which is 2xy over 2y minus x squared, and we're basically proving how we got there. So, my work is I began with separating the problem into two separate parts, y squared and negative x squared y, which I changed into f of x squared and a negative x squared f of x. So I applied the chain rule to the first portion to get 2y y prime, and I used the product rule for the other portion, and I got my final product as negative 2xy minus x squared y prime. And so I combined them back together, and I moved over whichever of the portions didn't contain y prime as to isolate it. So I moved over to 2xy, and so I isolated the y prime from these two parts. And so y prime, I removed y prime from both and was able to divide both sides by 2y minus x squared. And so I was able to prove y prime is equal to 2xy over 2y minus x squared. And that's how you do A. And so for B, for B, it asks you to write an equation for the tangent lines of the curve at point 1, 3. So what we would do here is then plug in points 1 and 3 back into the problem. And so we would back into the derivative of our formula. Oh, my bad. And so we'd get 6 over 5. So then we can get the slope, because we know that the derivative of a formula, once we find the derivative, we can use that to measure the slope at a certain point. And so by finding the slope, we'll be able to find the tangent line at that specific point, which is 1, 3. So after we find the slope at that specific point, we can plug it into the formula that gives us the value or the actual function of the graph, which is, or of the tangent line, which is y minus y, like y1 minus y2 is equal to m parentheses x1 minus x2, and we're able to plug in our values for x and y, for y2 and x2, and also our slope for m. So after we do that, we just move the 3 over to the right, and we distribute the slope for x and for negative 1. Oh, sorry. And so we get our final product, or our final solution, as 6 over 5x plus 9 over 5. And that's our equation for the tangent line. And so now we are asked to find basically the y coordinate of P. So show that there's a point P with x coordinate 0 at which the line tangent to the curve at P is horizontal. So what we would need to do here is basically what we need to do here is plug in 0, which is the half of the point P we were given, back into our formula, our base formula, which was our original y squared minus x squared y is equal to 6. So we plug back in for x 0 into that formula, and from that we're able to evaluate that y is equal to positive negative square root of 6. And since we know that we're solving for y is greater than 0, y must be positive square root of 6, because as we've been given before, y is greater than 0. So we can't take the negative version of square root of 6. And so we're able to just get from our y point and plug it back into point P. And so we're able to determine that there's a horizontal tangent at 0, positive square root of 6. And for D, we're solving for the value of d squared y over dx squared, which is basically asking for the second derivative of our problem. And so what I had to do was a lot of math. There was a lot of math involved. It's basically taking the derivative of the derivative. And so, yeah, here's just all my work for it. There was a lot of chain rule and product rule. Like, basically, you have your first derivative, and you need to take the derivative of that. So first you separate the 2 from the top, or the numerator, just like put it off to the side. And then you can basically apply the quotient rule, where you have f of x on top and g of x on the bottom. And so what you'll need to do is apply the quotient rule, which is like f prime of x times g of x minus f of x times g prime of x. And so after doing all that math, and simplifications, you're able to simplify it down to this formula, which you're given, which is 2 parentheses x cubed, yada yada. And so you're not done there. You still need to solve for, as said by the problem, solve for the value at the point P found in part C. So since we solved in part C, we were able to solve it. We can now plug back in the x and y values from part C into our newly found second derivative of the curve. So what we do is just plug back in to the problem our point P. So first we need to simplify it a bit more, or not simplify, but just make it easier for us. So since our final product, our final answer had a y prime in it, we are able to basically substitute the y prime in our problem for the derivative, or the first derivative, because we know that y prime is equal to the first derivative, which is xy over ty minus x squared. And so we're able to just plug that in for y prime, so that we're actually able to plug in for all of our x and y values. So after plugging in for our x and y, we're able to basically just do the math and solve it out. And so we're able to, after doing all the math, we can simplify it down to 2 times negative 12 over 24 with a negative on the outside, which negatives cancel each other out. And after we're done with all of that, we're able to reach our final answer, which is 1. And yeah, that is how you're supposed to do number 2 of the FRQs. Thank you.